Hello, welcome to lesson 3.5. This is actually the last lesson in unit 3, and we're going to be working on solving logarithmic equations today. So let's start with something that's pretty basic. For a question that looks like this, where there's just one logarithm, kind of over here by itself, you're going to do what I refer to as the logarithm song. And so this is if you haven't watched the logarithm song video, make sure you go back and do that. But the logarithm song tells us to rewrite it as an exponential equation. So that process is starting with the base of the logarithm. That becomes the base of an exponential. You raise it to the power of -3, and all of this will be equal to x. So to solve this equation, you just need to figure out what 3 to the -3rd power is. That would be the same as 1 over 3 to the 3rd power. And 3 to the 3rd power is 3 times 3 times 3, which is 27. So 1 over 27 is the answer to this question. Number 2 actually has a couple different ways that you could solve this. I'm going to show you what I think is the simplest of those options. And so in order to do that, I'm going to first divide by 24. And the reason I'm doing that is because I want to isolate the part of the problem that has the exponent in it, because I'm trying to figure out what x is. So I'm trying to get closer to that x. So that's going to give me 1 over 4 on the right side if we simplify all the way down. Again, what I can do here is I can do the logarithm song because I have an exponential equation and I can turn that into a logarithm. So take the base, which is 1/2, make it the base. Take the outside, make it the inside, and then take the exponent and make it the other side. So this is what my equation would look like. And I do encourage you to do this without a calculator. I know it's messy, but it is possible to solve this without a calculator. So then we would start over here at the logarithm, and we would try to figure out what this is equal to. So log base 1/2 of 1/4. That in your head, what you need to do is think 1/2 to what power is 1/4? 1/2 squared to 1/2 to the second power is 1/4. So this is all equal to 2. And then I'm pretty sure you probably know what to do from here. You're just going to multiply by 3 and get an answer of 6. All right, example 3 is very confusing at first glance. It might look like something that maybe is familiar to you. So I'm actually going to have you think of this as a polynomial. So do you see how this has e squared and this is, or e to the 2x and this is e to the x? Essentially what I'm trying to say here is this problem can be treated the same way as a quadratic equation. So if you know how to solve this thing over here on the right, then you'll use that same procedure to solve this equation. So let me start over here. If I were solving this equation on the right, wouldn't we be factoring first? So I would get x minus 4 times x plus 1, okay? You're going to do the same thing over here with your exponential equation, except instead of x minus 4, you'll have e to the x minus 4 and e to the x plus 1. So this exponential equation we have here is actually factorable, and it would look like this. Let's go back to the right side. Now, if we were solving on the right side, our next step would be set each parentheses equal to 0 and solve, right? Same thing for the problem that we are dealing with. So I'm going to set each of my factors equal to 0, and we're going to solve. Okay, so I'm going to end up with e to the x is equal to 4. Now the tricky part comes here because you're solving for x and you have e to that power is equal to 4. To solve this little equation, you're going to use a logarithm. Take the base, make it the base. Take the outside, make it the inside. Take the exponent, make it the other side. So log base e of 4 is equal to the value of x. And log base e, remember, is the same as the natural logarithm, which is we call ln for short. And since we're not using calculators on these questions, that would be the answer, ln of 4, okay? I'm going to go to the other half of this problem, and I'm going to solve it for e to the x, and then do the logarithm song again. And so now our job is to figure out e to what power is -1. That's actually not computable. So you're going to say no solution. Remember that logarithms have to have numbers larger than 0 right here to be able to compute them. All right, just I think 2 more examples. So it's kind of a short lesson. For this example number 4, we have basically a product rule property that's been showing here on this left side. So the first thing we're going to do is we are going to apply the product rule, and we're going to condense this back into a single logarithm. Remember, plus means times in logarithm world. I also have a 2 on this right side that can be written as a power. So that's going to make this, instead of x, just x squared. Now at this point, you have a logarithm on both sides. And that's actually a good thing, because remember, when you're solving an equation, the goal is to make the left side equal the right side. Well, the left side has a ln and the right side has a ln. So that part of the equation is already equal. What's not equal is all of this stuff is obviously not equal to x squared. So since you have a ln on both sides, you can kind of disregard those at the moment because they're already the same. And you can focus your energy to this inside stuff. So you need to figure out how to make this left side equal to this right side. Okay? So what you've just done is turned a logarithm problem now into just a regular old polynomial problem. So your next move is going to be to distribute and put all your terms on one side. Combine like terms as you go. And then once we get to this point here, we're going to factor. So I need, let's see, I need +2. So I need a double negative to make a +2. And I need 2 times 1. I think that's going to work. So then we can solve each of these products for x. And we're going to get 2 answers. X is equal to 2 or x is equal to -1/2. Now, new thing right here. Logarithms have restrictions, okay? Logarithms, the x value has to be greater than 0, okay? Logarithms don't work with negatives. So that means that your answers need to be checked. So it's real simple. You're just going to take your answer and you're going to plug it into each logarithm and make sure that it does not give you a negative. And this first value of 1/2 is going to give us a negative inside this logarithm and inside this one over here, which means that this is incomputable with 1/2 as an answer. So remember that when an answer is solved and it doesn't actually work, it's called extraneous. So 1/2 is an extraneous solution. 2 is going to be just fine because it would give us positive numbers when plugged in. So 2 is your actual only answer. Last example, number 5, we're going to be using properties again. So we're going to do the product rule here because I see a plus sign, and we're going to condense this back into a single logarithm. So that means that these two things will then be multiplying each other. It's a little different than the last time because I don't have a logarithm on both sides. So what you're going to do is you're going to do something similar to example number 1, and you're going to rewrite this as an exponential equation. So take the base, make it the base, take the outside, make it the exponent, take the inside, and make it the other side. And while I'm at it, I'm going to go ahead and distribute this x. 3 squared is 9. And we are going to then subtract 9 to get all of our terms on one side. And then factor. So this, I think, will factor to x minus 9 times x plus 1. And that gives us x is equal to 9 and x is equal to -1. Now, our original equation had logarithms in it, so we have to take the extra step of checking our answers. So is 9 going to be okay as far as giving us positive values inside? Yes, 9 is good. -1, though, if I plug a -1 in here, it makes a logarithm that's not computable. So this value is extraneous. That is it. Nice short lesson for today.